All right, hello once again. This is Jeff Scott. I've been talking to you about the Microsoft Security Development Lifecycle, or SDL, and the time has come to discuss or have a presentation solely on threat modeling. All right, not only am I going to give this presentation, there'll be a couple of them on threat modeling, and then I'll also show a demo on how to threat model. So, as we get started here, this is one of the Microsoft presentations. So as you can see, we'll talk about how to threat model, how to use the STRIDE, which is a Microsoft way of doing things, per element approach to threat modeling, some rules of thumb. The exercise is not in here in the demo, so. All right, when you start looking at all of the things that are in here, all right, and you've got in here SDL threat modeling. Threat modeling is an unbelievably important part of the security development lifecycle. The sooner it can be done in the lifecycle, the better you are. When you think about it, when you're threat modeling, what you are trying to do, in essence, is you're trying to go through your system and you're trying to figure out what the possible threats might be. Now, there's two ways that you can do this. The first way is you can get a bunch of people together, and typically when you do this, it's mainly security people, and you brainstorm. That has both advantages and disadvantages. The advantage is you get people with a like mindset, people who are knowledgeable, in the know, so to speak, getting together to come together, hopefully at least, for a common purpose. The bad news is that when you get a lot of those people together, quite often things can break down. People have their own agendas, etc., and things, what you think is going to get done might not necessarily get done. The other way that you can threat model is to use some threat modeling tools, and that's what we're going to start to talk about. All right, and we'll get into it a little bit in this presentation, but more in the next presentation. Typically, in that case, what you'll do, at least following the Microsoft SDL guidelines, is you'll get together and first you'll have some kind of a contextual or high-level data flow diagram that's been created. People will come together and agree that indeed that is the system that's being modeled, that is the type of thing that we're talking about, etc. And once that's done, then the next step is to go in and actually start to discuss the associated threats. So again, that would be your second step. All right. Then once you've done that, there are automated tools that Microsoft has that are designed to indeed help you threat model. All right, and we will talk about some of those in particular. We'll look at data flow diagrams, but Microsoft has had their own threat modeling tool for several years. It was very much refined in 2014, but then fortunately, I guess, for us, in October of 2016, they came out with Threat Modeling Tool 2016. So you're going to see a demo of that a little bit later. All right, so who are you threat modeling against? As it says, the bad guys. You don't know who they are, you don't know when they'll strike, you don't know how they'll strike. All right, what are you threat modeling? As it says, what you're trying to do is you're trying to come up with a process that will find and address all threats to your product. Now that's a very healthy goal, for lack of better words. Is it possible to find and address every threat to your product? In an ideal world, yes. The problem is there might be threats out there that you don't even know about, something that you would never have thought of before. But the idea is, in this process, you're trying to identify and address all threats to your product. When, again, as we mentioned, the earlier you start, the cheaper it'll be because you've got more time to plan and fix. Code typically hasn't been written yet. If you have to modify the design somewhat, you're able to do that, etc. But you don't just do it at the beginning of the project. You should do it partway through the project to make sure that indeed all of the threats that you've identified have been addressed. You should do it right before you release the project to make sure that all the threats you've identified now indeed have been mitigated. The worst case, as it mentions right there, is you're now ready to ship and you find problems. Or even worse than that, you've already shipped the product out and you find problems. Okay? Why do you threat model? You want to find problems as early in the life cycle process as possible so they can be fixed. It is a Microsoft SDL requirement. It allows you to deliver more secure products, which will help your reputation. So how do you threat model? Well, again, this is how it's done at Microsoft. They've got some kind of a program manager who's in charge of the overall process. They bring in testers, they bring in developers, they bring in everybody you can think of. Typically, they'll bring in security people. They'll probably even bring in one or more marketing people, people that don't have the expertise, because you want the product to be looked at with as many different types of sets of eyes as possible. All right. For your customer, you want to also illuminate them. You might have to educate them as far as different things that can happen, especially if you're about to ship a product, or you've just shipped a product and now you discover there's an error. Well, you might want to tell the customer about it and say, do you want us to pull the product and fix it? Do you want us to turn the feature off by default, where you can turn it on an as-needed basis, etc.? So as it says, these are overall guidelines, and you need to decide what fits your overall organization. All right, so always be documenting your security stuff. As it says there, document the product as a whole, security relevant features, document your attack surface. All right, what you're trying to do here is you're trying to be as complete as you possibly can from the beginning. If you pardon me for a second, I'm going to go in and I'm going to insert the slide number. Okay. All right. One of the things we talked about in a much earlier lecture is the fact that what Microsoft is attempting to do is they're attempting to produce software that's secure by design. So in other words, security has been baked in from the beginning, and the use of threat modeling is a way of doing this. All right. Why? Again, because attackers think differently. What you're told to do as a really good security tester is to think like an attacker. The problem with that is quite often attackers are all over the board. They might try one thing one day, and if they have little to no success, they might try something totally different the next day. Ideally, as it says here, what this is going to allow you to do is to predictably and effectively find problems, again, as early as possible in the process. So how do you threat model? This is an example here of a more higher level data flow diagram. All right. What you see here is the things that are circles, those are processes. Anything that's rectangle here, these rectangles, all right, down here, these are your data stores. And anything that you see down here, the bigger rectangles, those are external entities. Now, some of these rectangles that are between here, these are data flows, the arrows, and the arrows can only go in one direction. In other words, you can't have a double-edged data flow. But for example, here, this is just the name of that data flow. So here, this is an external data source. Most of the rest of the things that you see here, as far as things that are rectangles, those are just the names of your data flows. So again, what do we have here? Circles, which represent processes, what you're trying to threat model. All right. The big rectangles here, which are your external data sources, those are your things where you're going to potentially have the most problem, because anytime you're getting data from an external source, all right, that's a place where the attacker might want to literally attack. The double lined here, these are your data stores, typically a database. All right. The dotted lines, they represent trust boundaries. Again, that's typically something where you've got some kind of an external connection, but it's something, again, where you have to go and you have to possibly go in to try to do some threat mitigation. Once you threat model, you match those threats up against the Microsoft STRIDE structure. So S, spoofing; T, tampering with data; R, repudiation, or the fact that you can claim you didn't do something and they can't prove you did; I is information disclosure, D is denial of service, and E is elevation of privilege. So when you look at this, you'll notice that the process is the biggest thing to threat model because the process is open to any of the 5 types of threats. External entities, all right, these are most open to what? Spoofing and repudiation. Data stores to tampering, information disclosure, and denial of service, and possibly repudiation. That's why it's in red. And finally, the data flows, again, tampering, information disclosure, and denial of service. So this is the process for using Stride in a nutshell. All right, you identify your threats, you mitigate the threats. So in other words, you try to come up with ways of solving the threats, and you validate. Well, first you diagram, then you identify your threats, you mitigate, and you validate. All right? So you first go in and you do diagramming. I don't want to read this to you, but again, what they're talking about, what you should have is a much higher level drawing than this one. It might only have a few symbols on it, but you need some kind of an agreement between everyone in the organization over exactly what it is you're about to talk about. So that's when they say start with an overview. Okay? You check your work. Are we missing anything? Does it match reality, etc.? Then you go in and you start drawing more detailed DFDs or data flow diagrams. As mentioned there, you include all of the symbols, including processes, data stores, external, or data flows, trust boundaries, etc. You should update the diagram as your product changes. This is another documentation tool. Any assumptions you're making, any dependencies you're making, they should be put out there from the start and they should be agreed upon. Ideally, if you're doing this manually, you'll want to number everything. If you use the Microsoft tool, it's much harder to do. So again, these are your symbols. You've got your external entity, and as it says, people, but the biggest thing there is other systems, because that's something that at least potentially you can be getting information in from another source. So that's going to have to, of course, be validated. Your process, typically that's associated with your code. Your data flow, which is typically associated with arrows coming into something, meaning an input, and arrows going out of something, meaning an output. A data store, which most often is equated with either a database or a file. And a trust boundary, when you're talking about the relationship between these different elements. As mentioned here with trust boundaries, add them that intersect data flows. Notice point surfaces where an attacker can do things they're not supposed to do. So you've got different kind of boundaries, and examples are shown there. Processes talking across a network almost always have a trust boundary. What you're looking for, again, what you're trying to diagram, what you're trying to enumerate, are places where an attacker would be most likely to try to get into the system. So you iterate over that when you get done. And you say, okay, now that we're looking at this, maybe we've identified 1,000 different places where the attacker can potentially get into the system. Out of those 1,000, maybe half of them make no sense because it would be so difficult that it would be literally impossible. Or it would be like saying that we're going to build a car, and that car is going to be totally set up so that no matter what kind of accident it gets in, it won't be damaged. The person who's inside, there won't be such a thing as a car accident that can kill someone. Could that be done? The answer is yes, but how much would a car like that cost? I don't know. I mean, I don't work for the automobile industry. All right. So as you do that, as it says, how to know when it needs to be broken down further? Well, you look at it. Much of it is experience. If you're not sure if it needs to be broken down more or not, the chances are it probably does. So here's a high-level context diagram. You'll notice that all we have here is a process, all right, some kind of an external entity. I couldn't think of the word, sorry about that. And you've got data flows between them. This would probably just be shown typically as just one arrow. But that's what's going in, that's what's coming out. Then you break it down into what's called a level 1 diagram. So there's a little bit more detail in it. You'll see that again, you're identifying your trust boundaries, which are red dotted lines. You're identifying your data stores, which are your open-ended thing, which typically again are either files or databases. You've got your circles, which are your processes. You've got your data flows, again, your data coming into the process and flowing out of the process. All right? And you've got your external entities. Once you get agreement on that, all right, you have to figure out how much more detailed do I want to be. So context level diagrams are sometimes called level 0 diagrams. So what you're doing here is you go from context to level 1 to level 2 to level 3, etc. You're getting more and more detail. As it says, rarely will you need to go more than layer 3. You don't want to do what, get into what's called analysis paralysis, when you're just spending all of your time documenting and diagramming. You have to start working and fixing also. So should you go from the top down or should you go from the bottom up? In other words, should you go from the top down, from the general to the specific, or should you go from the bottom up, from the specific to the general? By and large, it works better if you go from the top down. As it says there, you might have more work from the start, but going from the bottom up, you typically have more work overall. All right, some rules of thumb. Here we've got a web server, and we've got two different data flows, but they're both flowing out of the system. In other words, how did that data flow into the web server? There's no inputs, there's only outputs. You can't have that. So here would be an example of what you'd want to add. As it says, data comes from external entities or data stores or even other processes. Here it says, are there data sinks? So we're writing, but nothing's ever happening here. In other words, the data is dying in your SQL server database. So typically you'd want to be sending that someplace. All right, data doesn't flow magically. In other words, not from one data store to another data store. There should be some kind of a process in between it. Data flow diagrams are not flowcharts. There are other tools that can be used. There are UML tools and other tools that can be used. All right. One of the reasons that data flow diagrams are used is there are only 5 or 6 different symbols, and we've already seen them. In fact, the trust boundary isn't a typical data flow diagram symbol, that dotted line. It's something that Microsoft came up with. It's pretty much been accepted. But there's only about, like I said, 5 or 6 different symbols. If you use UML, there's about 80 symbols. All right. So they've got a contextual level diagram here of somebody protecting a castle. So you've got a local user who's coming in and trying to get into the castle. So this, and again, here's a remote castle, here's your trust boundary. The castle service itself is a process. When you see a double circle like this, what that typically means is that's a process that has to be broken down further. And they've done it here. This is just, for lack of better words, this is almost a mess. All right. So once you've diagrammed, then you have to go in and start to identify your threats. Again, you can brainstorm, and quite often you do. But not everyone in the room will probably be a security expert, so Microsoft has come up with this stride model. Now notice what it is. It says that you can spoof. What you want is authentication. You can have tampering. What you want is integrity. You can have repudiation. What you want is non-repudiation. You can have information disclosure. What you want is confidentiality. You can have denial of service. What you want is availability. You can have elevation of privilege, and what you want is authorization. So when you think about it, spoofing means somebody getting in, and breaching the security, not being authenticated, going in as somebody they're not. With tampering, you're talking about being able to physically change the data. With repudiation, you're talking about going in and being able to do something, and then later, if you're called on it, being able to say, no, I didn't do that, and they can't prove you did. For information disclosure, you want confidentiality. You don't want things released like maybe something as simple as names and addresses. Maybe something as complex as social security numbers or credit card numbers. You want availability. And when you think about it, one of the examples, or the thing that we're going to threat model in a different lecture, is we're going to talk about somebody coming in and trying to withdraw money from a bank. All right? And when you think about it, if somebody comes in every day, so if I walk into a bank every day and I claim to be someone I'm not, and let's just say that after a while I kind of become a running joke with the bank. They don't call the cops, they don't do anything. But I come in and I say I'm John Smith. And they ask for identification and I show them my license and they go, you're not John Smith. Well, let's just suppose that they don't do anything about it. They just let me keep coming in every day. And maybe this happens 2, 3, 4 days. Now they threaten if I come in again that they're going to call the police. All right, so I don't come in again. But during that interim, they go in and they decide that the real John Smith, they're going to put a freeze on his bank account. All right, until they get this whole thing settled. So now the real John Smith comes in, shows who he is, and they say, we're sorry, you can't withdraw money because there's a hold on your account. So me, as an attacker, going in and doing that, I have created a denial of service for the real John Smith. All right. Finally, with the elevation of privilege, this is probably the most dangerous one because I can go in and literally be someone I'm not. All right. So let's look at these in more detail. Okay, spoofing, impersonating someone or something else. Tampering, modifying data or code. All stuff we've already looked at. Repudiation, claiming you did not perform an action. Information disclosure, exposing information to someone not authorized to see it. Denial of service, denying or degrading service to users. Elevation of privilege, gaining capabilities without proper authorization. And if you say, there seems like there's some bleed between these, there is. And you'll notice, again, we already looked at this in an earlier slide. Your external activities, again, spoofing and repudiation. Your processes, everything across the board. Your data stores, tampering, possibly repudiation, information disclosure, and denial of service. Your data flows, tampering, information disclosure, and denial of service. So once you go in and you start doing this and you start looking at each element, then what you have to do is you have to figure out, again, okay, we've identified, let's say, 100 different attack points through our threat modeling. Out of these 100 attack points, what we've done is we've given gauges, so to speak, to each one. So we've said what are the chances of it happening, etc. All right? So you go in and you do all that, and then you can come up with some kind of guide or something. You say, no, which should we start working on? All right, so you're going in here and you're showing, technically, if something is a process and it's possibly is going to be open to any kind of threat, that's what you want to start with. Some things you'll have probably little control over. If they're external entities, you might have very little control. If you've got an application that needs to have an internet component to it, all right, as an example, you might not have total control over that part of it. Trust boundaries, as it says, validate everything for specific and defined uses. Make sure your errors don't give away too much, so write generic error messages. Notice what it says, don't worry about these threats. Some things you're not going to have control over. a user attacking themselves, an admin attacking a user. Unless you're the operating system, as it says, you probably won't be able to do too much about these. All right, so now we have to come in and start talking about mitigation. Mitigation is addressing the problem, ideally alleviating it. Why? You want to protect the customers, you want to protect your own software. All right, it says, why bother if you create a great model, you identify a lot of threats? Well, you want to then, after you've identified those threats, you want to come in there and you want to fix them. Here's Microsoft's way of doing it. You address each threat, and there's 4 ways of doing that. Number 1, you redesign rather to eliminate. The good news is if you typically use this method, the threat will be gone. The bad news is it's going to take more time, it's going to take more people, it's going to take more money. Number 2, you apply standard known mitigation techniques. So as it says, what similar software packages, what similar problems have you had or somebody else had, and how were they fixed? Number 3, you invent new mitigations. And as it says, it's riskier because, again, it will take time, it will take person power, it will take money, but even more importantly than that, if it hasn't been tested yet out in the field, as it says, it's riskier. Or you accept the vulnerability in the design, you let the customer know about it, and you have them say, well, maybe you should turn that feature off by default, we'll just turn it on when we need it. And after you've addressed the threat, if you come up with the ways of doing it, then you have to actually try to go through and do your mitigation. So again, what they show in the right-hand column here, I'm not going to read a bit of this, but what they're showing is how to mitigate against threats, spoofing, tampering, etc. You'll notice that there are prevalent themes here: ACLs, 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 which are, of course, are access control lists. Mitigations are an area of expertise. So in other words, okay, the people who do this have to be trained to do it and have to know what they're doing. It says their amateurs make mistakes, but so do pros. Typically, though, the difference might be the degree of magnitude. So in other words, you might have a pro make a mistake, but the effect of that mistake might be marginal. Whereas if an amateur makes a mistake, if they forget to do something, all right, it's not impossible that the results could be catastrophic. Mitigation failures will appear to work until an expert looks at them. When you need to invent mitigations, get expert help, because maybe you don't have the training or whatever that's needed. So they go through an example here. Again, I'm going to leave this stuff with Doug. It's fairly complex, so I'm just going to skip that. Finally, we want to go in and we want to validate what we've done. As it says, we want to validate the entire threat model. Does this diagram match the final code? Have the threats been enumerated? Do we at least know what they are? Have we run stride on it? Have we mitigated the threats, and have we mitigated them correctly? Did we go through this before we do a final security review? If we have, our shipping will be more predictable, our customer will be happier, our reputation will be better and stronger. Validate quality of threats and mitigations. Notice for the threats. And notice the mitigations. Fuzzing, which we'll talk about in a later lecture. All right, you've got basically positive and negative types of fuzzing rather. With positive, what you're doing is you're putting in valid inputs to make sure the system works the way it should. With negative fuzzing, you're basically going in and putting in outrageous inputs to see how the system reacts. But when you're fuzzing, what you're trying to do is you're trying to guarantee that the system works as it should. And if there are output or are inputs that are put in that are not standard inputs, that the system can survive, let's put it that way. But as it says, it's a way of testing, it's not a way of mitigating. For these dependencies and these assumptions, remember that your product typically will not live in a vacuum. Again, if it's the kind of thing that has to interface with the internet, all right, you have to look at that too. You have to look at your product, and maybe there's just a little part of it you're changing, whatever it happens to be. So maybe it's a new release or a new version of a product. But you have to make sure that by you adding some new feature that you haven't opened your product up to a threat for some existing feature that it wasn't there before. You've got to note every assumption. All right? So they give some more sample mitigations here. I'm not going to go through those. We've talked about this. Develop draft threat model before a meeting. The idea is you start by walking through your context level DFD. Then you go into maybe a little higher level and you start to identify. Now it says there, identify the most interesting threats, all right, or elements. Well, I wouldn't put interesting in there, but probably the ones most likely, whatever assets you have that are most likely to be desired by an attacker. All right. You also want to go through your different entry points and your different trust boundaries. You want to use the stride mechanism against those. All right. And you want to work accordingly. What they asked you to do here in this exercise, and I don't have a copy of it, was to number all the different flows and then add the trust boundaries and match the stride to each one. All right, so kind of to conclude here, when you're identifying threats, be specific, make sure you understand both the threat and the impact of the threat. All right, identify first order mitigations. What's the most natural way of solving this? Start early, track your changes, have some kind of a security guru that's involved. Make sure everybody knows about any assumptions you've made. Learn all the time. Try to become more and more of an expert. Microsoft Magazine has several articles on threat modeling. Microsoft has a SDL blog. They have books on threat modeling, etc. Some more resources. I believe that's just about it. These are called backup slides. They're just extra stuff that was added. All right? So that's all I've got for this presentation.